ice-covered craters, and searing heat. Before we introduce you to this unique planet and the fascinating images from NASA's Messenger mission, we'd like to ask you to subscribe to our channel, activate the notification bell, and like the video. If you enjoyed the video, we'll start with a brief overview of Mercury and the Messenger mission overseas. Mercury is a planet of contrasts because it is the smallest of the current 8 official planets and orbits the Sun in the closest orbit. Despite its proximity to the Sun, researchers have discovered signs of water ice. Find out how it got there and what mysterious processes are going on inside Mercury in this video. Music, Mercury, and the Messenger. Before the first measurements. From telescopes gave completely different impressions. Researchers believed that Mercury was a relatively barren and dead celestial body, similar to our Moon, consisting primarily of rocks, dust, and dryness. There were even growing indications that organic substances and even water could exist on Mercury. In 2004, NASA launched its Messenger spacecraft to ascertain whether water actually exists on Mercury and how the planet's interior is structured, among other things. The term messenger refers to Mercury's surface, space environment, geochemistry, and range. For the Romans, Mercury was a messenger of the other gods in his divine position. On March 18, 2011, after almost 7 years of flight, Messenger entered its orbit around Mercury, and researchers from all over the world were excited to see what messages Mercury and its first educated probe would have in store for Earthlings in the 1970s. Mariner 10 was the first NASA probe to fly by Mercury Messenger. However, was the first probe to orbit Mercury. The mission lasted 4 years, and during this time Messenger was able to revolutionize the scientific view of Mercury. Some things we already knew from intensive observations of Mercury with telescopes. But no observation from afar can match what probes can measure and observe up close to the planets. First impressions of Mercury. Mercury has only a very thin atmosphere, so it can barely hold temperatures and gases. It's almost defenseless against the interplay of brightness and darkness and the influences of the Sun. While Mercury's day side is more than 750 degrees Fahrenheit, temperatures drop to an icy minus 290 degrees at night. Messenger not only had very good cameras on board, but also highly sensitive measuring instruments and excellent spectrometers. Thanks to these technologies, researchers were able to gain unique new impressions. Soon, Messenger was able to confirm that Mercury not only has an iron core similar to our Earth, but that this iron core must also be active in some way. Therefore, Mercury is not a dead, cooled-down rock world. Its interior is likely undergoing transformation processes, and its surface exhibits signs of volcanism. Based on current observations, researchers also believe that Mercury may be churning liquid portions in its interior. Clues to this are provided by intriguing impressions of the planet's surface and the astounding size of its liquid core, which makes up 85% of the total volume beneath a relatively thin solid crust. There is a separating layer that contains iron sulfide, followed by a voluminous liquid middle layer and a very large solid core. It is still unknown why Mercury has such massive amounts of liquid rock in its interior compared to its small size. These oddities most likely relate to the extremes that Mercury, as the nearest planet to the Sun, is subjected to. For the first time, a map of Mercury's distinct gravitational field has been produced owing to Messenger. Mercury's magnetic field is only around 1% of Earth's, and it is shifted away from the planet's central axis. As a result, the magnetic North Pole is roughly 20 degrees from the geographic North Pole, making it highly asymmetric and 3 to 5 times stronger in the north than in the south. Additionally, the south of Mercury is significantly more impacted by solar plasma currents. Mercury has severe abnormalities and an odd extra rotation because of its close proximity to the Sun and the curvature of spacetime caused by the Sun's mass. Another oddity of Mercury is that it completes 2 orbits around the Sun by rotating precisely 3 times on its own axis. If you were on the planet's surface, you could see that the sun rises to a specific point in the sky and then sets backwards along this exact orbit. Because of the irregularities in Mercury's orbit, the sun may even rise twice on a Mercury day, which would provide us with a rather bizarre sight. Earthlings' volcanism on Mercury. At first glance, Mercury's cratered surface resembles Earth's moon, and for a long time, researchers thought Mercury's surface structure was formed by impacts from comets or asteroids, but MESSENGER's data revealed something. Else the craters on Mercury's surface are by no means exclusively the residues of impacts, but are the result of a hitherto unexplained and probably unique geological activity in the solar system. The measurement data of MESSENGER could confirm that a large part of Mercury's surface was formed by volcanism in the past. However, there seem to be no active volcanoes on Mercury's surface today. Instead, there are strange craters that were most likely formed by uplifting and lowering of the thin crust, as well as minimal ejections of material from Mercury's interior. The strange depressions indicating these peculiar geological activities are unlike anything geologists have ever seen in the solar system. Whether this is related to a previously unknown type of subsurface volcanism cannot yet be confirmed. The researchers found evidence of large areas that were once flooded with molten lava, similar to that on Earth, because Mercury shows such a vast liquid interior and in an apparently active surface of some sort. Researchers suspect large magma reservoirs in the upper liquid layers of the planet's Mercury is the Caloris Basin. Possibly a volcano. Researchers long assumed that one of the most prominent depressions on Mercury was the impact basin of an asteroid-sized body. The basin, about 900 miles in size, probably formed about 3.9 billion years ago, since MESSENGER could detect a 1.5 to 2 mile thick lava layer inside the Caloris Basin. Volcanic openings probably formed after the impact. In this color-enhanced image taken with a spectrometer, the lava layers are shown in orange. Thus, the Caloris Basin on Mercury is most likely a unique mixture of an impact crater and an extinct volcano water ice on Mercury. It seems paradoxical that there is water ice on the planet that should be the hottest due to its proximity to the Sun, but on the one hand, Mercury is not the hottest planet in the star system. This title goes to the neighboring Venus, and on the other hand, Mercury has regions at its poles that lie in the permanent shadow of the Sun due to the displacement and rotation of the planet exactly. There, MESSENGER could confirm what researchers already suspected since 1991, the occurrence of water ice. How the water came to Mercury is still unclear. The most common theory so far says that water and ice are distributed in the solar system by comets. After a collision, the ice of the comet is transmitted to the planet. Nevertheless, this is far from explaining all occurrences of water on planets. In experiments, scientists were able to simulate that water. Molecules can also be formed by a combination of solar wind and the surface heat of Mercury's dayside. Chemical actions within the regolith rock lead to the formation of water molecules, which then rise as vapor. Most of this water evaporates, however. Depending on Mercury's region and position, certain portions of fine water vapor may waft around the planet and precipitate as ice at cold craters at the poles. The long tail of Mercury. The mystical messenger of the gods, Mercury is a truly exciting and unique planet. Because of its great speed, it occasionally trails a luminous tail. Mercury is the only planet in the solar system where this phenomenon, which is normally only common with comets, occurs. Mercury's tail is made up of fine dust particles, or, more specifically, particle streams from the planet's upper layers that are blown up by the solar wind. Thanks to MESSENGER's measurement data, the size and extent of the tail could be precisely recorded for the first time. At times, the tail extends up to 1.5 million miles into space, extending more than 1,500 times beyond Mercury's planetary radius. The tail then shortens and expands again for a while, giving it its distinctive orange color from the high sodium content in the swirled dust layer. At the end of this video, we'd like to show you the most stunning and amazing images MESSENGER took of Mercury. Although Mercury is frequently shown as yellowish on planetary charts, it is actually grayish. The world in full color. Scientists can determine which elements are involved from the color patterns and can read variations in elevation on Mercury's surface from the coloring of young craters that appear in this image in light blue or white. When Mercury is viewed with different spectrometers, the coloring results from the filtering of elements. These images appear beautiful and colorful to the amateur observer. Large deposits of dark minerals are shown by the dark blue patches. Conversely, the reddish-brown parts are desert-like patches of rock and dust that were originally created by molten lava outbursts. These pictures display two of Mercury's biggest impact craters. We bid farewell to the celestial messenger of the gods Mercury with this breathtaking photo. We hope you enjoyed this video and left a comment, sharing your thoughts on the discoveries on Mercury and the enigmatic processes occurring within the planet. Thank you for watching, and we hope to see you again soon. MENA and MNSQ were formed by impacts from asteroids more than 1 billion years ago.